So number 9 gives us two equations. Both equations contain x and y, so we've got a system of equations. And they ask us to figure out what the solution to the system is. So there are several different ways you can go about solving this. If the calculator was in play, you could find a way to use a graph on the calculator to do it that way. This is a no calculator question though, so we're going to have to go with something different. What I noticed about this is my equations weren't necessarily both in standard form. Right, my x's and y's don't really line up perfectly within the original format of these equations. I definitely can manipulate them so that my x's are in this column, my y's are in this column, then my equal sign, then the values without x's or y's attached to them on the other side. If I wanted to make that rearrangement, I could then try to find a way to use elimination, but I'm going to use substitution. I think substitution is something that can be used in a lot of SAT problems, not just the ones that are asking you to solve systems. Elimination is specific just for solving systems like this one here. So I'm going to use substitution, and with substitution you need to look at the original equations, figure out how to solve either of them for either of the variables. So I noticed that this x had a coefficient of -1, and that's why I wanted to go ahead and isolate that x. So I added the x to the right hand side, I added the 19 to the 2y, and I figured out that x was equal to 2y plus 19. So I'm going to be able to substitute the x in the opposite equation out for what I just figured out x is equal to. Now, one thing that could kind of mess you up here if you're not careful, if you substitute into the same equation, you're not going to get anything to work out. You're actually going to get an identity equation, which doesn't get you to the point where you're able to develop the solution of the equation. So definitely make sure you substitute into the opposite equation in step 2 here. Watch your grouping symbols. So I have 3 as the coefficient of x. So when I replace x with 2y plus 19, I definitely have to use parentheses. I can then distribute to get rid of those parentheses. I have some like terms here. The 6y and the 4y get me to 10y. I want to isolate y, so I want to move that 57 to the other side. So subtract 57 from the -23 that's already there. Finally, divide both sides by 10, and you get the answer for y of -8. Now, as long as you're confident that you've done everything correctly there, especially if you're crunched for time, as you would be on the SAT, you can look at your options and realize that the answer is definitely going to be option B. It's the only one that gives us an answer of -8 for y. But if you had time, if you wanted to do a quick double check just to make sure you get the proper answer for x, you can substitute this back in place of the y in that substitution equation that you built in step 1, and then 2 times -8 plus 19 does give me 3 for x.